Hello, everybody. Today is May 2nd, 2024. We are meeting for our Secret Store CSI community meetings. This call falls under CNCF Code of Conduct. Uh, we have a light agenda today. We have Glenn Johnson today from CyberArk, and they have written a provider for our Secret Store CSI driver. So I think we can get started. Glenn, over to you if you would like to demo us and show us what you have.
Okay, sure. Am I cool to attempt to hijack the screen share? Okay. I think I may need you to unshare first. It's saying I can't share while someone else is sharing.
Okay, let me stop sharing now. Cool, go ahead.
Yep. Or I'm not used to Zoom. All right, you should be able to see my screen, but let me know if not.
Yep.
Okay, cool. Was that a yes? You guys can see my screen?
Yeah, we can see your screen.
Yeah.
Okay, cool. All right, well, I'll go ahead and get started. This will probably be pretty quick. I guess first I'll start by talking a little bit about Conjur, which is maintained by CyberArk. So Conjur is essentially a sort of RBAC type system targeting authenticating machines and workloads and basically delivering secrets to them. Oftentimes it's backed by CyberArk Vault, which is a separate product, but frequently organizations already have that and they'll use a synchronizer service to provide secrets to Conjur, and then Conjur itself provides a model for accessing them, including a set of REST APIs and integrations for retrieving them. So there's an enterprise and an open source flavor of Conjur. Obviously, for this purposes, we're focused more on the open source version of it, which is really forms the basis for the enterprise version too. They have the same APIs and integrations for the most part. Enterprise just has some additional functionality for targeting enterprise customers, but open source can do basically all the same things. So the full docs are on CyberArk's website. There's also the open source repo under the CyberArk org. I won't talk too much about it, but you'll see a little bit of what maybe makes it different from some of the other providers, I guess, when I get into the actual code of the end-to-end test, which is, I think, the best way to kind of highlight differences and how it works. So yeah, this is the open source repo for Conjur itself. The provider, which is kind of a recent effort from my team, which is the community and integrations team of Conjur, is also publicly available. It's deployable via a Helm chart, which lives in a separate repo, but we'll show that in the demo. And yeah, there's a README. There's also docs on the same CyberArk website. But as far as what we're going to sort of cover as part of the demo or the end-to-end testing, it's pretty much covered in the README. You'll notice it's basically exactly following what the usage section of our README shows. So one, I guess, aspect of how Conjur works and is maybe different from other providers is the way the RBAC is configured is via policy, which is this YAML format you'll see here and also in the demo itself. So essentially, Conjur works by creating roles and resources and via this YAML format that you load into it, which it stashes in the database. In the case of the provider, we're going to basically set it up as a host identity, provide some sort of metadata on it, the namespace and the service account that it's expected to be running as in the cluster. We also need to configure an authenticator instance. So there's a handful of different ways to authenticate Conjur. Most commonly for Kubernetes, it's either certificate-based or JOT-based authentication. So in our case, we're using auth and jot, which is essentially going to pass through a jot token from the Kubernetes API server to Conjure to authenticate the workload. There's a couple different ways you can configure it. The simplest, I think, is to provide the public keys of the API server as well as the issuer, which is essentially the URL of the API server or expected to be. And lastly, as part of configuring our workload, we're giving it the ability to authenticate through this auth and jot web service that this policy represents and creates. And lastly, things like variables and secrets are also configured via policy. So you'll see in the test as well as here, we're loading a policy that is essentially setting up our dummy test variables that we're going to use to validate that secrets are coming through to the application pod correctly. And we're giving the workload host the same privileges to be able to read or execute against those variables. So yeah, there's a bit more in here about actually deploying it via the Helm chart and configuring, but I'll just show that as part of the actual end-to-end code demo. All right, so yeah, I have a PR open in the main secret store CSI driver repo. I think it still needs an approval to even be able to run the tests, but I basically have followed a pattern that I noticed for other providers. And I'll save the actual code, I guess, for the script for last, since that's kind of boilerplate. Same really for the manifest. So I'll show the policy. So the policy is essentially what I just showed from the README. We're creating a workload host, which is going to be our provider, and as well as letting Conjure know the namespace and the service account. We're setting up some dummy variables that workload host can retrieve, and we're configuring our authenticator with the sort of minimal set of variables to be able to authenticate the workload. Beyond that, it's just we have our manifest, which we have an inline volume test without rotation, referencing the Conjure secret provider class. We have a separate one for rotation that's, I think, otherwise essentially the same. And we have the separate secret provider class defined here. So I guess I'll talk a little bit about the syntax or the required parameters, I guess, for our provider. In configuring the Conjure provider, we need to provide a few things. So the account is essentially just a Conjure specific way of organizing policy. In our case, we're just using default. The appliance URL is essentially the root endpoint of the Conjure service inside the cluster in this case. The authn ID is the authenticator ID. So that policy that defines the authenticator essentially is going to be used to build the authentication endpoint, and the host ID, which lines up with the policy as well, and the secrets mapping, which in our case, the syntax follows this pattern of the key is the path that it will be volume mounted to, or I guess it's appended to the path of the actual volume mount. And then the value is the path to the secret in Conjure policy. It also needs the SSL certificate to make requests to Conjure in the case where we're using like a self-signed cert or a cert in the cluster. So yeah, beyond that, I guess we'll go to VS Code, so it's a little more readable, but beyond that, we're basically just have a BATS test script that I think follows the pattern of most of the others. There's a couple differences and a little more setup maybe required than some of the other providers that I noticed in working through it. So I'll walk through it a little bit. So one thing is that I'm not sure what bootstrapping happens in the actual like workflows of you guys' CI, but one thing that does need to be set is we need to generate a token from the Kubernetes API server with Conjure as an audience. As well as I applied a couple things to enable rotation. I'm not sure if that's necessary in the real case, but this was required to get it to run locally on my system using Kind. So yeah, we're just patching the main secret store CSI driver deployment as the first step. Then we go through and deploy Conjure as well as the provider itself. So like I said, Conjure has its own Helm chart. They're both in the CyberArk repo. And then we also separately install the CSI provider. So we're setting up a basically vanilla instance of Conjure as well as the provider itself. We're doing some configuration on Conjure. So we need to create our account, which is default. We stash the API key. We're spinning up a instance of our CLI to do a few things to load the policy, or I guess the 3 policies in this case. So you'll see that as part of this. This is all running in our CLI pod, where we're passing in like the API key and whatnot to authenticate as the admin user, as sort of a pre-configuration. We're setting up our test variables. We're setting up our authenticator variables so that we can authenticate our workload. And yeah, from there, it's, I think, pretty much follows the pattern of everything else. We need to deploy our secret provider class. I think I already have I hard-coded the secrets mapping. Yeah, in the secret provider class. So yeah, this is the same as what's in the PR, but everything's defined here except for the certificate, which is being retrieved via the environment variables. So yeah, that gets deployed. We deploy our inline volume test test pod, which I think is just a busy box container, and we're printing out and comparing the mounted secret and comparing it to the expected. So yeah, everything else is pretty much cookie cutter. I also added a rotation test, which again does basically the same thing, but has a sleep added to it and confirms that the rotated value gets read from the pod or mounted into the pod. So yeah, that's really it as far as the code. I've been running it locally exclusively, and it works with just a plain kind cluster. So I'm curious to get some thoughts when anybody has a chance to review and see how it works in the CI pipeline. And yeah, if anybody has any questions or comments or anything, I'm happy to spend a little more time on any part of it. Oops.
I just had one question, right? So like the only service account tokens that you use is the one that's generated by the driver and passed on to the driver, right? You don't generate anything on the Conjure provider.
No, we're not generating anything. So I think, yeah, I noticed that it passes, I think, the full array of tokens. So there's the one that we configure here, which has the audience of Conjure, and then there's the one that has like, I think the Kubernetes API server as an audience is kind of the default. So yeah, this is the only one that we need, but we don't do anything to generate it aside from updating the secret store driver Helm deployment.
I have another one, like the vault. I mean, the vault that you guys have, right? If it is, let's say, storing secrets in like a JSON format, right? Do you have any templating in a provider which will able to sort of mount those secrets individually? So, for example, like you have the value in your vault as a JSON, which is itself like a probably a multiple key value pairs. Like, do you provide any templating to separate it out and mount them as an individual secret, or you expect only just like a plain value in your vault which you fetch as is and then mount?
So Conjure itself and APIs don't inherently do any massaging of the data, I guess, that is retrieved. So
Right.
yeah, it'll always come through as a string. Some of our other integrations will have things built in for that, for like decoding base64, writing things as templates, combining values, et cetera. But for this integration, no, it would just come through as like the raw value from the Conjure database, essentially.
Right. And once you receive those values, do you do anything in provider after you received it and before sending it to driver for mounting?
Oh, right. No, we do not. At least not that I'm aware of. But I don't don't think so.
Okay, cool.
Is that a feature that other providers have? I'm not totally aware of, like, I guess the use case, but
Right, we're thinking about it, and there were like a couple proposals and a PR around it. So I was just like curious if with this particular provider and what, which is it's connecting to, has some similar requirements or these. So I was just curious about it.
okay, cool. Yeah, we actually maintain something called Secrets Provider for Kubernetes that has a lot of the same functionality as, I guess, a provider in this context, in that it reads from Conjur and injects secret values into either Kubernetes secrets or volume mounted files. And that has support for like templating of the output file. If you have a series of values that should form like a JSON or a YAML file, you can define templates for that, but it's a bit heavier of an integration, and has kind of gotten a bit bloated over time. So it's nice to have something like this. It's like more lightweight and more standardized than that separate integration that we maintain.
Is that separate integration an open source project?
It is, yeah. So
Okay. Just to give you a little context, right? Like today, the driver mounts the secrets in the volume, but in addition to that, we had this optional feature which also enabled you to sync the mounted content as Kubernetes secret. You might have looked at the docs in the driver. So we as a community are actively working on separating those two features out. So we have this new repo that we have created called Secret Store Sync Controller, which uses the basics from the Secret Store CSI driver, right? So it uses a secret provider class. It uses the same interface for communicating with the provider. So it would use gRPC, and the exact same set of providers that are supported for driver would automatically work for this controller. But the idea is driver will only mount the secrets in the volume, and that's it. That's the only functionality which we would encourage. And the controller going forward will only sync as Kubernetes secret. So it'll talk to the provider the same way it does today. And then once it gets the secrets back in the RPC, it would go and sync those as Kubernetes secret, which might be very similar to like this project that you're sharing now.
Yeah, essentially it sounds like it. And yeah, we didn't, I don't know if this is typical, but we didn't do any additional work around supporting the Kubernetes secret case. But I think it does work. So it seems like it's kind of isolated to the driver itself. But yeah, we did not bake in any of that functionality as part of our provider. So it shouldn't have much of an impact, but it's good to know that it's being separated out.
Anyone
And yeah,
else?
so
Sorry.
go ahead. I was going to talk a little bit about the secrets provider, but there's really not much to cover it. The way it works is instead of using like the CSI interfaces, it secrets provider runs as a container. Essentially, you can either run as an init container and inject the secrets on like app pod startup, or it can run as a sidecar alongside your application pod to enable like refreshing of secrets and volume mounted secrets over time. So it's a little bit different and a little more heavy on configuration. So yeah, that's really all I have to say about it.
I was going to make some comments. So Anish just briefly spoke about the whole new controller bit. So one of the things that's interesting is it will still reuse the same RPC interface between outside thing and the provider. So instead of the driver calling the provider, now it'll be the controller calling the provider. And obviously they have to be in the same pod because it's over UDS. One of the differences there is because it's not the kubelet calling the provider, the only support we'll have for identity being passed through for like the associated workload is the service account token. So if you're relying on like node publish secret, that won't work in that mode. But
okay.
So that's just me letting you know, and as like a slight difference between the two things. You might not care if you're not using it. The other thing I wanted to ask about was, I assume it's probably not a hard requirement to run all these components in cluster, but since that might be at least somewhat common, since you support JOT verification, I was curious if you guys had any plans on supporting like token review. So that's the API that the Cube API server exposes and lets you validate tokens using it instead of like being configured with like what's the signing or the public keys.
We do, yeah. I think we just don't make that assumption for the case of this test, but the JOT authenticator that we have for Conjure, I actually don't know where the best documentation source for it is, but there's a handful of different ways it can be configured, including like under the assumption that Conjure has access to the Kubernetes API server, and when it doesn't, so we assume that it may not in the case of this deployment, just because it's a little bit easier to configure, but there's a handful of different ways to do it. You can provide just the JOX URI, and then Conjure, assuming it can reach the API server, will verify it sort of on the fly instead of having the public keys provided as like a static value. So yeah, there's a handful of different ways it can handle it. These are all like sort of optional and a bit confusing of which ones are needed when, but I think there's better documentation somewhere. But yeah, it can definitely do that.
Okay, that's good to know.
Okay, in terms of next steps, how we can look at the PR. So there's one PR in the driver, but there also needs to be another PR in test infra because a new job needs to be added. We can share the examples on Slack, like for providers that we did. But these two PRs are the first things that need to be reviewed. And then once that is done and the test passed, then we'll also like look through the code once just to see what if you're following the common pattern that other providers do. And I think the last is basically like adding the provider to the list.
Okay, so yeah, sounds good. Yeah, let me know what else I need to do. I can open another PR for having the test run.
Yeah, the repo is in Kubernetes. It's Kubernetes actually.
Okay. Well, I'll check it down.
Yeah, so that's where we would need to just set up a new job for the provider. But I'll share the details like on Slack.
Okay. Good. Sounds good. Yeah, and if you guys need a code review at all, I'm happy to help facilitate that. I mean, obviously it's available, and there's not a whole lot to it, I think. Just a couple packages, but I'm happy to sit on that as well. Or if there's any questions that come out of it, feel free to let me know.
Thank you.
Sure. Thanks, guys. And I'll keep an eye on the Slack more than I have been, just in case anything comes up. But otherwise, yeah, thanks for listening, and I appreciate a review when you guys have time.
We'll take a look. Thanks.
Cool. Thank you.
Don't think we have any other agenda item today. Does anybody have anything you want to discuss? No, Anish.
I was just gonna ask how's the controller PR coming along?
Yeah, that's what I was gonna talk about too. So I added that as an announcement, like just so that it's on the community call. So like we have the new repo. There's already an existing PR that's being reviewed. So I saw the contributor like Andrea pushed out a few more changes. So I think it's on us to look at it this week, and then if we can merge that, then Nilay can continue working on it. Nilay, if you want to add any details.
No, so yeah, I think we talked about this before offline, I guess, but Andrea is still gonna continue and finish up that PR. So we'll wait. Alex, who was in the call before, I guess, he might be able to help us as well. So action item on me is to just set up another sync probably, just to make sure that we are aligned on that. So I'll do that. Okay, anything else? If not, I think maybe we can conclude the call then at 30 minutes back. Thank you, everybody. Talk to you later. Bye bye.
Thanks. See ya.
Bye, all. Take care.